Hello everyone, welcome back to another video. So here is the code base and I will walk you through the code base step by step so that you can be able to understand how it works. So we only have two files, one is app.py and the second one is chatbot.py. So inside the app.py basically we have wrote all the front end code. So it's nothing but just a 33 lines of code which will be just a front end part. Okay, so that's an easy part. Okay, but the real challenge is in the chatbot.py, and here I will tell you how we can build it step by step. So yeah, let us go ahead and start. So basically what we are going to use is we are going to use LangChain for building this. So inside the LangChain, when you go in the LangChain documentation, you can just find this learn tab. Okay, just go on that learn tab and just go inside this LangChain, just go inside the RAG agent, and yeah, that's it. And we are going to start implementing it. So basically what we are going to build is we are going to build a question answering system on any of the websites. So website chatbot basically you can say. So one of the first thing you will have to do is just go ahead and install this all the libraries. Why LangChain is important? As we are going to use LangChain, the LangChain text splitter is basically the AI model can't actually handle a lots of tokens at the same time. That's why we use this LangChain text splitter, and LangChain community is for all the community imports, and BS4 obviously as we are going to scrap the websites, and that's why we will be needing this beautiful SOAP4 library. Alright, so just go ahead and let us see what the documentation says. Okay, LangChain, Langsmith, we don't need Langsmith as of now, but yeah, in future if we want to integrate Langsmith, you will just have to go ahead and get the Langsmith API key from the Langsmith, and yeah, that's it, and you are ready to go. But yeah, that's not the part of the current tutorial, right? We will be seeing about the Langsmith in future videos as well. That's so not a problem. Okay, so in this tutorial I have used Google Gemini model, as basically if you will use OpenAI, Anthropic or Azure OpenAI models, though those models are basically paid. So I feel is Google Gemini actually gives you the lots of free credits. So yeah, you can just go ahead and use the Gemini model, and for practice or for learning purpose, this is more than enough. You get a lot of credit from Google. Okay, so we will just go ahead and use this as well, and yeah, let us go in the code. So what actually we are building? We are building a RAG system. So what is RAG? RAG is basically you can see here LangChain has given the document, given a kind of a diagram which tells you what is RAG. So RAG is basically you can just do the question answering over a kind of external knowledge base. So what does external knowledge base means? Just like for example, you can have your personal data in the PDF form or in the document form, or even you want to do question answering over some website. So that is kind of a external data. So that's the thing, we are going to do question answering over the external data. External data can be anything. So the first step in the RAG, you will have to always load the document. That's it. The always one of the first step while using RAG is to load the document, be it anything. Document can be your document can be in the docx as well as in the PDF format or anything. Image, it can be image also, it can be URL as well. So once you load the data, you will convert that data into a document object. So you will convert it. Before that, you will have to split the data as um, um, as because of the token limitations. Okay, so once you get the data, you will just split it, and then you will store it in the form of embeddings in the vector store. And what is vector store? Vector store is basically just a special type of database where you can store the embeddings. So what does embeddings means? Embeddings, as a high level, for now you can just consider it as embeddings are just the numerical representation of the given data. That's it. And yeah, once you store the data, and once you store the data in the vector store, you will basically able to retrieve the data. Yeah, that's it. So yeah, let us get started. So before starting, let us install the important dependencies we need. So in this we will need LangChain stack splitter, all this stuff. Okay, just go ahead. I have already created the virtual environment. So yeah, but don't forget to create a virtual environment basically. Okay, so I will just go ahead and install according to the documentation. And yeah, that's ahead. Let's go ahead, and you can just go ahead and install this Google Gemini package as well. And once you've done that, you can just go slowly down. Yeah, here also we are using this. So yeah, okay, so basically we have installed it, and we are going to start the implementation. All right, so they are what they are actually doing is they have installed the LangChain Google Gemini package, and right now they are importing the embeddings. And we also need a model, right? So basically for the chat completions we need a chat model, and for converting these um, natural language natural language data into a numerical format, you need a embedding model. So Google also provides a embedding model. So yeah, that's it. And yeah, you can see here how they have imported this class, and the class has a attribute which where you can set to model whatever name it is, right? Okay, then that's it. And just go ahead. So let us go ahead and see it in the code. Basically what happens is you will just go ahead and import all the necessary documents. For example, you have .env, you will import load.env, right? And also LangChain from LangChain.agents, you will import create agent, and that these are the, and then tools, and then from here web based loader. So basically what happens is you have to load your data, right? So while loading your data, you can have different types of data, right? Like from one will be PDF, one will be URL, like URL will be from a web, right? So basically for PDF you will have different type of loader, which is PyPDF loader, as well as while you are going to use websites, you will be needing this web based loader. Yeah, you can see from the documentation as well. What they have do is what they have did, import bs4, and again from the LangChain document store, LangChain community document store, they have imported web based loader. And with the help of this web based loader, we can load our website into the documents, and we can create the document object using this loader, web based loader basically. Okay, so they have given a website, they have hard coded it basically, but we are not going to hard code it, right? As we are going to pass the data at the runtime. So just like that we have did it over here. We are going to use FAISS as a vector store in the end. We are going to use Gemini embedding as well as chat Google generative AI model. And if you want to know where did I got this information, you can just go ahead in the LangChain, and here you can see there is this model section. Just go ahead, scroll down, and here you can find it, Gemini. And if you want to read more about the Google Gemini chat models, you can just go ahead, and here you can see there are different information. For example, what are the environment variables it uses, the how we are going to create the instance of this chat Google generative AI class, and all the stuff. You can just check the model, you can just change the model from model parameter, And yeah, that's it. There are different options. You can use file upload as well, you can use image, a PDF input. There are lots of options, right? So that's it. If you want to learn about this in detail, just ping me in the comment, or just I will make the video around it. But yeah, these are the different possibilities available with this Google GenAI model offers you. Like, you have 2.5 flash image model. What it basically does is, basically you can just go ahead and it just go ahead and generates the images. This model is for generating images. This model is also for generating images, etc. Audio generation is there available via Google Gemini API, right? Using this model. Okay, so yeah, let us go back, and that's it. Let's yeah, okay, so we have imported all the important libraries, and after that we are going to create a function which will be load and index websites. So basically what we are going to do is, we are not hard coding our website URL. Instead, we are going to get this URL from the user who is going to use it. Okay, so that's why we haven't hard coded it. And after that, we have created loader equal to web based loader. Then we are going to do the loader.load, and then we are going to split the documents as a recursive character stack splitter, and where we are going to give the size chunk of 1000 and chunk overlap to be 200. All right, yeah, that's it. And then we will create all the text, all the split basically, and the splits will be split via text splitter dot split document, and over there we are going to pass this docs, and that's how we can get the complete chunks of the data. And this is just error handling. If there is no doc uploaded, then yeah, just it will throw the no content extracted from this URL. And if not, if the split's not there, then we can just raise a value error which will say like could not split content into chunks. And after that, what we have to do is, after that we are going to create a embedding. So let's see what is the step after this split. There is the embedding step, right? So basically we will just go ahead and initialize our embedding model. I have used Gemini Embedding 001. You can use anything. And vector store equals FAISS. We are going to use this FAISS as our vector store, and from documents we are going to pass in the splits and the embedding model. So you can just see here, it takes these two arguments, and yeah, that's it. And after that, we are going to return the vector store. And finally, the most important part, here we are going to start building our RAG pipeline. Okay, so this is it, and that's really easy. So we are basically, what we are doing here is, we are basically defining a tool, and a tool is nothing but it is just a function which can be called by the LLM whenever the function is related to whenever the task given to the LLM is related to that function. Okay, so let's say you can see this string over here, right? So basically, what does this string suggest to our LLM? This string helps our LLM to understand what tool to call at what time by reading this description. Like what it says, retrieve all the information to help answer a query. So yeah, that's it. And here we are going to go ahead and pass in one parameter, which is query. And query is basically user can ask question over the documents, right? So basically you will just go ahead and first of all do the similarity search over the query and the top k chunks, how many chunks you want to retrieve. Then here you can specify with k equals. So you just basically, I can write 3, you can write 4, or anything. I mean, yeah, it depends on your it depends on you. I have just hard coded it as 4 for now. So yeah, after that, once we get the document, we will just go ahead and return the retrieve docs And that's it. And after that, what we are going to do is we are going to create our model. And once the model is created, we will just create such a prompt, which will basically you have access to a tool that retrieves the context from website whenever so basically what does this means is whenever you will get a website and you have to basically do the question answering over that website, you will just go ahead and use this tool. That's it. Okay. Yeah, after that we are going to create the agent. And the agent is basically nothing, a model along with tools. That's it. Nothing else. So basically you will just go ahead and create agent using this create agent, and inside there you can just pass in the model and the retrieved context. And retrieve context, basically it is basically this is the tool name. You will just go ahead and pass it over here as a list, and then there is also a system prompt. That's it. And this is your agent, and you will just go ahead and return the agent. And yeah, that's it. And the final moment, the final function which is responsible for doing the question answering is this def ask function. So you will just go ahead and pass the agent and the question, and that's it. You will just go ahead and you will just loop in the agent.stream, and after that you will just go ahead and pass in the messages. In the messages, you will go ahead and pass the user message as, and the content will be the question passed in the parameters, right? And after that you will go ahead and save the final message as step of messages, and the last one, the last message from the given JSON. All right. And after that you will just go ahead and return the content, basically by formatting it actually. That's it. And after that you will go ahead and connect this backend. I mean, it's not a kind of backend, but you can just say it Python script, and you will just have to connect it with the UI, right? That's why we are using this Streamlit. So we have imported Streamlit, and from this chatbot file we have imported this function. All these three functions we have imported. Over here we have setted the configurations like st.title, caption, everything. You can just beautify your website as much you want, but yeah, for now this much is I feel good. So yeah, that's it. And here you can just go ahead and take the input as st.text input, and here you can just go ahead and save with the placeholder. Like, yeah, here you will have to paste your website. And if URL if user pasted the URL and click the button, then only we will be going to start the spinner. And when the spinner will start, inside there we are going to do a try catch block, and here everything will happen. You will just go ahead and load the website using load and index website function. After that you will just go ahead and update the station state of the of the front end. You will just go ahead and pass in the vector store to the build RAG agent. After that you will just go ahead and that's it. The if the embeddings got created and vector store has been created successfully, then you will see this message. Otherwise you will see some error, exception as E. You will just go ahead get this error message. That's it. And after that you will just go ahead and start chatting. If and here you can just set the message roles of the users, basically. And you will just go ahead and write the content of the response. So if the user input is whenever there is user input, you will just go ahead and pass this user input to the agent, right? And how we are going to pass this to the agent using this ask function. And here, before passing it to the passing it to the agent, we will be going to write this function. And once we get the response back from our agent, we will just go ahead and write it in our messages list. And that's it, we are done. And I will just go ahead and run the application again. Streamlit run app.py. So yeah, let us say this time we will be going to give this LangChain website, and let us see how it works. What is RAG? And boom guys, we can see that we have got the response back from our agent we have passed this documentation of the LangChain, right? We can just go ahead and ask it how the RAG agent can be created using LangChain. And yeah, that's it guys. To create a RAG, you can just use the indexing, then you will just go ahead and load the document, split the document, store it in the vector store, then retrieval and generation. That's it. So yeah, that's it for this video guys. Thank you. If you like the video, please share and like and subscribe. Thank you.